Chapter 2. Is matter around us pure? How do we judge whether milk, ghee, butter, salt, spices, mineral water or juice that we buy from the market are pure? Some consumable items. Have you ever noticed the word pure written on the packs of this consumable? For a common person, pure means having no adulteration, but for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of the substance are the same in their chemical nature. A pure substance consists of a single type of particles. In other words, a substance is a pure single form of matter. As we look around, we can see that most of the matter around us exists as mixtures of two or more pure components. For example, seawater, minerals, soils, etc. are all mixtures. 2.1. What is mixture? Mixtures are constituted by more than one kind of pure form of matter. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical processes into its chemical constituents. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is the same throughout. Soft drinks and soil are not single pure substances. Whatever the source of a pure substance may be, it will always have the same characteristic properties. Therefore, we can say that a mixture contains more than one pure substance. 2.1.1 Types of mixtures. Depending upon the nature of the components that form a mixture, we can have different types of mixture. Activities 2.1 Do this. Let us divide the class into groups A, B, C and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate powder. Group B takes 50 ml of water and two spatula full of copper sulfate powder in a beaker. Group C and D can take different amounts of copper sulfate and potassium permanganate or common salt sodium chloride and mix the given components to form a mixture. Report the observations on the uniformity in colors and textures. Group A and B have obtained a mixture which has a uniform composition throughout. Such mixtures are called homogeneous mixtures or solution. Some other examples of such mixtures are 1. Salt dissolved in water and 2. Sugar dissolved in water. Compare the color of the solutions of the two groups. Though both of the groups have obtained copper sulfate solution, but the intensity of color of the solutions is different. This shows that a homogeneous mixture can have a variable composition. Group C and D have obtained mixtures which contain physically distinct parts and have non-uniform composition. Such mixtures are called heterogeneous mixtures. Mixtures of sodium chloride and iron fillings, salt and sulfur, and oil and water are examples of heterogeneous mixtures. Comment this. Activity 2.2. Do this. Let us again divide the class into 4 groups A, B, C, and D. Distribute the following samples to each group: few crystals of copper sulfate to group A, 1 spatula full of copper sulfate to group B, chalk powder or wheat flour to group C, few drops of milk or ink to group D. Each group should add the given sample in water and stir properly using a glass rod. Are the particles in the mixture visible? Direct a beam of light from a torch through the beaker containing the mixture and observe from the front. Was the path of the beam of light visible? Leave the mixtures undisturbed for a few minutes and set up the filtration apparatus. In the meantime, is the mixture stable or do the particles begin to settle after some time? Filter the mixture. Is there any residue on the filter paper? Discuss the result and form an opinion. Group A and B have got a solution. Group C has got a suspension. Group D has got a colloidal solution. Comment this. Filtration. A, B, C. Filter paper folded, cone of a filter paper. Glass rod liquid decanted in the funnel fitted with the filter paper, funnel, test tube, filtrate. Now we shall learn about solutions, suspensions and colloidal solutions in the following sections. Questions. What is meant by a substance? To list the points of difference between homogeneous and heterogeneous mixtures. Comment this. Two point two. What is a solution? A solution is a homogeneous mixture of two or more substances. You come across various types of solutions in your daily life. Lemonade, soda water, etc. are all examples of solutions. Usually we think of a solution as a liquid that contains either a solid liquid or a gas dissolved in it, but we can also have solid solutions, alloys, and gaseous solutions, air. In a solution there is homogeneity at the particle level. For example, lemonade tests the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. More no. Alloys. Alloys are mixtures of two or more metals or a metal and a non-metal and cannot be separated into their components by physical methods. But still an alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. For example, brass is a mixture of approximately 30% zinc and 70% copper. A solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it. Usually, the component present in larger amount is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. Examples. 1. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is the solute and water is the solvent. 2. A solution of iodine in alcohol known as tincture of iodine has iodine solid. As the solute and alcohol liquid as the solvent. 3. Aerated drinks like soda water etc. are gas in liquid solution. This contains carbon dioxide gas as solute and water liquid as solvent. 4. Air is a mixture of gas in gas. Air is a homogeneous mixture of a number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities. Properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nm, 10 to the power minus 9 meter in diameter, so they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution, so the path of light is not visible in a solution. The solute particles cannot be separated from the mixtures by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. 2.2.1 Concentration of a solution. In activity 2.2, we observe that groups A and B obtain different sets of solutions, so we understand that in a solution the relative proportion of the solute and solvent can be varied. Depending upon the amount of solute present in a solution, it can be called a dilute, concentrated or a saturated solution. Dilute and concentrated are comparative terms. In activity 2.2, the solution obtained by group A is dilute as compared to that obtained by group B. Activity 2.3. Do this. Take approximately 50 ml of water, each in two separate beakers, and salt in one beaker and sugar or barium chloride in the second beaker, with continuous stirring. When no more solute can be dissolved, heat the contents of the beakers to raise the temperature by about 5 degrees centigrade. Start adding the solute again. Comment this. Is the amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature the same? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. What would happen if you were to take a saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. The concentration of a solution is the amount, mass or volume of solute present in a given amount, mass or volume of solution. There are various ways of expressing the concentration of a solution, but here we will learn only three methods. 1. Mass by mass percentage of a solution, mass of solute by mass of solution into 100. 2. Mass by volume percentage of a solution equal to mass of solute by volume of solution into 100. 3. Volume by volume percentage of a solution equal to volume of solute by volume of solution into 100. Example 2.1. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. Solution: mass of solute salt equal to 40 gram, mass of solvent water 320 gram. We know mass of solution equal to mass of solute plus mass of solvent per equal to 40 gram plus 320 gram equal to 360 gram. Mass percentage of solution: mass of solute by mass of solution into 100 equal to 40 by 360 into 100 equal to 11.1%. What is a suspension? Non-homogeneous system like those obtained by Group C in Activity 2.2, in which solids are dispersed in liquids, are called suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Properties of a suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scattered a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. 2.2.3 What is a colloidal solution? The mixture obtained by Group D is in Activity 2.2 is called a colloid or a colloidal solution. The particles of a colloid are uniformly spread throughout the solution due to the relatively smaller size of particles as compared to that of a suspension. The mixture appears to be homogeneous, but actually a colloidal solution is a heterogeneous mixture. For example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes, but these particles can easily scatter the beam of visible light as observed in Activity 2.2. This scattering of a beam of light is called the Tendal Effect, after the name of the scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Torch A, B. Path of light becomes visible. A. Solution of copper sulfate does not show Tyndall effect. B. Mixture of water and milk shows Tyndall effect. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist consists tiny droplets of water, which act as particles of colloid dispersed in air. The Tyndall effect. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and makes its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. Table 2.1 Common examples of colloids: dispersed phase, liquid, dispersing medium. Type example: liquid, gas, aerosol, fog, clouds, mist. Solid, gas, aerosol, smoke, automobile exhaust. Gas, liquid, foam, shaving cream. Liquid, emulsion, milk, fish cream. Solid, liquid, sol, milk of magnesia, mud. Gas, solid, foam, foam, rubber, sponge, pumice. Liquid, solid, gel, jelly, cheese, butter, solid sol, colored gemstone, milky glass. They cannot be separated from the mixture by the process of filtration, but special techniques of separation known as centrifugation, perform activity 2.5, can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium, the solute-like component or the dispersed particles in a colloid form, the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of the dispersing medium and the dispersed phase. A few common examples are given in table 2.1. From this table you can see that they are very common everyday life. Questions? Comment this. Two point three. Separating the components of a mixture. We have learned that most of the natural substances are not chemically pure. Different methods of separation are used to get individual components from a mixture. Separation makes it possible to study and use the individual components of a mixture. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods like handpicking, sieving, filtration that we use in our day-to-day life. Sometimes special techniques have to be used for the separation of the components of a mixture. 2.3.1 How can we obtain colored component dye from blue or black ink? Activity 2.4 Do this. Fill half a beaker with water. Pull a watch glass on the mouth of the beaker. Put a few drops of ink on the watch glass. Now start heating the beaker. We do not want to heat the ink directly. You will see the evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. Observe carefully and record your observation. Comment this. Evaporation. Vapors, ink, watch glass, beaker, water. Now answer. What do you think has got evaporated from the watch glass? Is there a residue on the watch glass? What is your interpretation? Is ink a single substance pure or is it a mixture? Comment this. We find that ink is a mixture of a dye in water. Thus, we can separate the volatile component solvent from its non-volatile solute by the method of evaporation. 2.3.2 How can we separate cream from milk? Nowadays, we get full cream, toned and double-toned varieties of milk packed in polypacks or tetra packs in the market. These varieties of milk contain different amounts of fat. Activity 2.5 Do this. Take some full cream milk in a test tube. Centrifuge it by using a centrifuging machine for 2 minutes. If a centrifuging machine is not available in the school, you can do this activity at home by using a milk churner used in the kitchen. If you have a milk dairy nearby, visit it and ask 1. How they separate cream from milk, and 2. How they make cheese, paneer from milk. Comment this. Now answer. Comment this. Sometimes the solid particles in a liquid are very small and pass through a filter paper. For such particles, the filtration technique cannot be used for separation. Such mixtures are separated by centrifugation. The principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Application: used in diagnostic laboratories for blood and urine tests. Used in dairies and home to separate butter from cream. Used in washing machines to squeeze out water from wet clothes. 2.3.3 How can we separate a mixture of two immiscible liquids? Activity 2.6. Do this. Let us try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layers of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of water carefully. Close the stopcock of the separating funnel as the oil reaches the stopcock. Separation of immiscible liquids. Separating funnel, kerosene oil, water, stopcock. Applications: to separate mixture of oil and water in the extraction of iron from its ore. The lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. The principle is that immiscible liquids separate out in layers depending on their densities. 2.3.4 How can we separate a mixture of solid and camphor? We have learnt in chapter 1 that camphor changes directly from solid to gaseous state on heating. So, to separate such mixtures that contain a sublimable volatile components from a non-sublimable impurity, the sublimation process is used. Some examples of solids which sublime are ammonium chloride, naphthalene, and anthracene. Separation of camphor and salt by sublimation. Cotton plaque, inverted funnel, solidified camphor, vapors of camphor, mixture of camphor and salt, china dish. Separation of camphor and salt by sublimation. 2.3.5 Is the dye in black ink a single color? Activity 2.7. Do this. Take a thin strip of filter paper, draw a line on it using a pencil approximately 3 cm above the lower edge. Put a small drop of ink, water soluble, that is from a sketch pen or fountain pen, at the center of the line. Let it dry. Lower the filter paper into a jar or glass or beaker or test tube containing water so that the drop of ink on the paper is just above the water level, as shown in figure, and leave it undisturbed. Watch carefully as the water rises up on the filter paper. Record your observation. Comment this. Strip of filter paper, line drawn by pencil, a spot of ink. Glass rod, paper clips, jar, strips of filter paper, a spot of inks, water. B. Separations of dyeing in black ink using chromatography. Now answer. Comment this. The ink that we use has water as a solvent and dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particle. Usually a dye is a mixture of two or more colors. The colored component that is more soluble in water rises faster and this way the colors get separated. The process of separations of components of a mixture is known as chromatography. Chroma in Greek means color. This technique was first used for separation of colors, so this name was given. Chromatography is the technique used for separation of those solids that dissolve in the same solvent. With the advancement in technology, newer techniques of chromatography have been developed. You will study about chromatography in higher classes. Applications to separate colors in a dye, pigments from natural colors, drugs from blood. Two point 3.6. How can we separate a mixture of two miscible liquids? Activity 2.8. Do this. Let us try to separate acetone and water from their mixtures. Take the mixtures in a distillation flux, fit in with a thermometer, arrange the apparatus as shown in here the mixtures, slowly keeping a close water at the thermometer. The acetone vaporizes, condenses in the condensers and can be collected from the condenser outlet. Water is left behind in the distillation flux. Thermometer, clamp, distillation flux, water outlet, clamp, water, condenser, mixture of acetone and water, cold water in acetone. Separation of two miscible liquids by distillation. Now answer, comment this. This method is called distillation. It is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points to separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 K. Fractional distillation process is used, for example, for the separation of different gases from air, different fraction from petroleum products, etc. The apparatus is similar to that for simple distillation except that a fractionating column is fitted in between the distillation flux and the condenser. A simple fractioning column is a tube packed with glass beads. The beads provide surface for the vapors to cool and condense repeatedly, as shown in figure. Fractional distillations, thermometer, cork, water outlet, water condenser, pure liquid component, cold water in, cork, mixture, distillation flux, clamp, fractionating column. Two point 3.7. How can we obtain different gases from air? Air is a homogeneous mixture and can be separated into its components by fractional distillation. The flow diagram figure shows the steps of the process. Air compress and cool by increasing pressures and decreasing temperature. Liquid air allowed to warm up slowly in fractional distillation column. gases get separated at different heights? Oxygen, argon, nitrogen. Boiling point 0 degrees Celsius, minus 183, minus 186, minus 196. Percent air by volume 20.9, 0.9, 78.9. Pro diagram shows the process of obtaining gases from air. If we want oxygen gas from air, we have to separate out all the other gases present in the air. The air is compressed by increasing the pressure and is then cooled by decreasing the temperature. To get liquid air, this liquid air is allowed to warm up slowly in a fractional distillation column, where gases get separated at different heights depending upon their boiling points. Answer the following. Arrange the gases present in air in increasing order of their boiling points. Which gas forms the liquid first as the air is cooled? Comment this. Separation of components of air. Filter, air in, air under pressure, hot air, water out, freezing cold water in, cold compressed air, separator, carbon dioxide out as dry ice, liquid air, expansion, jet, nitrogen out, argon out, fractional distillation column, liquid oxygen. How can we obtain pure copper sulfate from an impure sample? Activity 2.9. Do this. Take some approximately 5 gram impure sample of copper sulfate in a china dish. Dissolve it in minimum amount of water. Filter the impurities out. Evaporate water from the copper sulfate solution so as to get a saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will obtain the crystals of copper sulfate in the china dish. This process is called crystallization. Now answer. Comment this. The crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystal from a solution. Crystallization technique is better than simple evaporation technique as some solids decompose or some, like sugar, may get charred on heating to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, this contaminates the solid. Applications. Purifications of salt that we get from seawater. Separation of crystals of alum fitkari from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we get a pure substance. With advancements in technology, many more methods of separation techniques have been devised. In cities, drinking water is supplied from waterworks. A flow diagram of a typical waterworks is shown in figure. From this figure, write down the processes involved to get the supply of drinking water to your home from the waterworks and discuss it in your class. Water purification system in waterworks. Reservoir to allow solids to settle. Sedimentation tank. to sediment the suspend impurities. Loading tank, fine sand, water, gravel, coarse gravel, filtration tank, chlorination, chlorination to kill bacterium, to home. Questions? Comment this. Two point four. Physical and chemical changes. In the previous chapter, we have learnt about a few physical properties of matter. The properties that can be observed and specified, like colors, hardness, rigidity, fluidity, density, melting point, boiling point, etc., are the physical properties, the interconversion of states in a physical change, because these changes occurs without a change in composition and no change in the chemical nature of the substance. Although ice, water and water vapor all look different and display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air, whereas water extinguishes fire. It is this chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings change in the chemical properties of matter, and we get new substances. A chemical change is also called a chemical reaction. During burning of a candle, both physical and chemical changes take place. Can you distinguish this? Comment this. Questions? Comment this. Two point five. What are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. Two point five point one. Elements. Robert Boyle was the first scientist to use the term element in 1661. Anthony Laurent Lavoisier, 1743 to 94. A French chemist was the first to establish an experimentally useful definition of element. He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reaction. Elements can be normally divided into metals, nonmetals, and metalloids. Metals usually show some or all of the following properties. They have a luster, shine. They have silvery gray or golden yellow color. They conduct heat and electricity. They are ductile, can be drawn into wires. They are malleable, can be hammered into thin sheets. They are sonorous, make a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Nonmetals usually show some or all of the following properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, coal or coke, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and nonmetals. They are called metalloids. Examples are boron, silicon, germanium, etc. More to know, the number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, mercury and bromine. Elements gallium and cesium became liquid at a temperature slightly above room temperature, 303 K. 2.5.2 Compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. What do we get when two or more elements are combined? Comment this. Activity 2.10. Do this. Divide the class into two groups. Keep 5 grams of iron fillings and 3 grams of sulfur powder in a china dish to both the groups. Group A, mix and crush iron fillings and sulfur powder. Group 2, mix and crush iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Groups 1 and 2, check for magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. Compare the texture and color of the materials obtained by the groups and carbon disulfide to one part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to the other part of. The material obtained. Note, teacher supervision is necessary for this activity. Perform all the above steps with both elements iron and sulfur separately. Comment this. Table mixtures and compounds. Mixtures, compounds. 1. Elements or compounds just mix together to form a mixture and no new compound is formed. 1. Elements react to form new compounds. 2. A mixture has a variable composition. 2. The composition of each new substance is always fixed. 3. A mixture shows the properties of the constituent substances. 3. The new substance has totally different properties. 4. The constituents can be separated fairly easily by physical methods. 4. The constituents can be separated only by chemical or electrochemical reactions. Now answer. Comment this. The gas obtained by group 1 is hydrogen. It is colorless, odorless and combustible. It is not as wise to do the combustion test for hydrogen is the class. The gas obtained by group 2 is hydrogen sulfide. It is a colorless gas with the smell of rotten eggs. You must have observed that the products obtained by both the groups show different properties. Though the starting materials were the same, group 1 has carried out the activity involving a physical change, whereas in case of group 2, a chemical change, a chemical reaction has taken place. The material obtained by group 1 is a mixture of the two substances. The substances given are the elements iron and sulfur. The properties of the mixture are the same as that of its constituents. The material obtained by group 2 is a compound. On heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. The composition of a compound is the same throughout. We can also observe that the texture and the color of the compounds are the same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organizer. Matter, solid, liquid or gas. Pure substance, mixtures, no fixed composition. Pure substance, element, compounds. Mixtures, homogeneous, heterogeneous. Elements cannot be broken down to simpler substances. For example, copper, oxygen, iron, hydrogen, mercury, etc. Compounds have fixed composition, can be broken down into elements by chemical or electrochemical reactions. For example, water, methane, sugar, salt, etc. Homogeneous, uniform composition. For example, sugar in a water, salt in water, sulfur in carbon disulfide, water in alcohol, etc. Heterogeneous, non-uniform composition. For example, sand and salt, sugar and salt, water in oil, etc. What you have learned. A mixture contains more than one substance, element and or compound mixture in any proportion. Mixtures can be separated into pure substances using appropriate separation techniques. A solution is a homogeneous mixture of two or more substances. The major components of a solution is called the solvent and the minor the solute. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. Materials that are insoluble in a solvent and have particles that are visible to naked eyes form a suspension. A suspension is a heterogeneous mixture. Colloids are heterogeneous mixture in which the particle size is too small to be seen with the naked eye but is big enough to scatter light. Colloids are useful in industry and daily life. The particles are called the dispersed phase and the medium in which they are distributed is called the dispersion medium. Pure substances can be element or compounds. An element is a form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements chemically combined in a fixed proportion. Properties of compounds are different from its constituent elements, whereas a mixture shows the properties of its constituting elements or compounds. Exercises. Do this and comment this. Group activity. Take a earthen pot, matka, some pebbles and sand. Design a small scale filtration plant that you could use to clean muddy water. Do this and comment this.